Welcome back, folks. Today we're going to be starting Chapter 4. Chapter 4 is going to be all about quadratics, and we're going to start with the forms of quadratics. We're going to start by trying to remember the difference between y is equal to the absolute value of x and y is equal to x squared. Remember, y is equal to the absolute value of x looks like a v, and we call those absolute values. While y is equal to x squared, it's the one that looks like a u, and we call those u's parabolas. All right, what exactly is a quadratic function? All it is a function with the highest degree of x being 2. Meaning that the highest power of x we have is squared, or 2. The vertex form for this looks like this. Y is equal to a times x minus h squared plus k. If this looks a little familiar, it's because it looks very similar to the function transformations we've done before. Vertex form is y is equal to a times x minus h squared plus k. Now let's draw a parabola so we can see what exactly these all refer to. I'm going to have a parabola starting here. Our maximum or minimum value right here, that's called the vertex. And our vertex in vertex form is just the point h, comma, k. So our vertex is the point h, comma, k. We have the line that the parabola is symmetric about, or the line where we could fold this parabola in half and the two sides would be the same. That is called our axis of symmetry. And the axis of symmetry will always be the vertical line. Vertical lines are always x is equal to, and it's just the point of our vertex, so it's x is equal to h. Other important information, a determines a lot of information. A determines whether we're stretching or compressing. If the absolute value of a is greater than 1, or if a is larger than 1, we are stretching. If a is going to be less than 1, that means we are compressing. And the positive or negative sign tells us we open up or down. So if it's positive, we open up. And if it's negative, we open down. Now the minimum is the smallest possible point. This will only occur on parabolas that open up. The maximum has to be the largest point, and it's only the largest if it's opening down. The vertex will always be the maximum or minimum value here. So it'll be a minimum when it's the smallest point when it's opening up. It'll be a maximum. It'll be the largest point when our parabola opens down. And these will both always be the vertex. Meanwhile, we're coming back to our old friends, domain and range. Domain is all the inputs or x values. Now for a parabola, or for a quadratic, the domain will always be negative infinity to positive infinity. The range, or the y values, will depend on whether it opens up or down. If the range, if we open up, the range is going to start at our minimum value, which is going to be the value of the vertex. So we'll start at whatever the value of the vertex is and go up to infinity. If we're opening down, however, then we're going to start at the vertex and work our way down. So our range will start at minus infinity and work our way all the way back up to the maximum point, or the vertex. Take a minute to write this all down. Then we're going to try practicing and applying this. We're going to try to create a sketch of each of the following. We're trying to identify the vertex and the axis of symmetry, tell whether the graph has a minimum or a maximum, and find the domain and range. So starting with this one, we have y is equal to x minus 2 squared minus 3. So that tells us our vertex is going to be h comma k, x minus 2 or minus h, so our vertex is going to be 2 comma 3. Let's go to 2 comma 3 and plot our point. Now from here, what we're going to do is let's figure out what the maximum or the minimum is. This is opening up. A is positive, so we're expecting this to go up. If it goes up, this will be a minimum. Our vertex, like we already discovered, is 2 comma 3. Our axis of symmetry is just the line running through our x point, so it's x is equal to 2. Our domain for any quadratic will always be minus infinity to infinity. And our range will be starting, because this opens up, starting at the bottom and going up, right? We expect this parabola to look something like this. So our range will start at 3 and go to positive infinity. Our range starts at 3 and goes to infinity. Now, how do we actually graph a parabola or graph a quadratic? Well, we're going to rely on a table telling us what values change for x and y. If we're looking at a normal squared equation, 1 squared will be 1. So this means going from the vertex, we'll go over 1 either way, because minus 1 squared is also 1, and we'll go up 1. Now what happens if we square 2? 2 squared is 4, meaning that from the vertex, if we go over 1, 2 spaces, we'll expect to go up 4. So we'll go up 1, 2, 3, 4. And the other way, we'll go up 4. And we can keep doing this if we need. 3 squared would give us 9. So if we have to go 3 places over from the vertex, we'd expect to be going up 9 spaces. Let's graph our parabola. And here's our answer. Right. Why don't you all try this next one? Tell me, what is the maximum or minimum going to be? What's the vertex? And what's the domain and range? Looking at this equation, we can rewrite it as y is equal to minus x minus 0 minus 3. So 0 is h, minus 3 is k. Our vertex is 0 minus 3. So let's put that down. We go 0 minus 3. Now, are we opening up or down? What's the sign out in front of our parentheses? It's negative. So we're going to be opening down. If we're opening down, the graph will look something like this. So we know we'll have a maximum. As always, our domain for a quadratic is negative infinity to positive infinity. And our range, well, this is opening down, so it's going to start at minus infinity, and it's going to go all the way up to negative 3. So these are our values. Now let's go ahead and look at our graph here. Now, all we have to do to change this and to make sure we're graphing right is we're going to multiply y by whatever our a value is, whatever our coefficient is. So instead of going 1, 1, 2, 4, 3, 9, we're going to multiply each of these y values by minus 1, because a is minus 1. So instead of going over 1 and up 1 each way, we're going to go over 1 and down 1. We're going to go back to the vertex. We're going to go over 2. We're going to go down 4. And this is going to be a basic sketch of our graph. We have one more over here. The key thing to remember is this becomes x and not y, but our a value here is 2. So 2y, if we're multiplying 1, 2, or 3, 1 squared is 1 times 2. So we're going to go up 2. 2 squared is 4. Times 2, we're going to go up 8. And for 3, we'd go up 18. You can try this one on your own if you would like. What about going the reverse way? How do we write the equation when we're given a graph? Well, we know vertex form. Vertex form was y is equal to a times x minus h squared plus k. Meaning that if we can find our vertex, we can solve for h and k. Let's go ahead and do that. Our vertex, our maximum point here, looks to be all the way up there. So we're going to go, that's 2, 16. Meaning that this equation will become y is equal to a x minus 2 squared plus 16. And now the only variable we have that we don't want in there is a. How are we going to solve for a? Well, we're going to take a second point and solve. So let's take this point over here that's already been marked out. That's the point 4, 12. And we're going to substitute that into our equation to solve for a. So x is 4, y is 12. This becomes 12 is equal to a times 4 minus 2 squared plus 16. Or this will become minus 4 is equal to a times 2 squared. Minus 4 is equal to a times 4, or a is equal to minus 1. So we got h and k from our vertex. We got a from substituting in a second point. And our final equation will substitute both of these in. So y will be equal to minus 1 times x minus 2 squared plus 16. And that will be our answer. Go ahead and do that with problem 1 over here. Let's do problem 2 actually. Points are easier to see. This point down here is 3 minus 4, and we have a couple of other points to choose from. Go ahead and do that. Tell me, what is the equation in vertex form of this parabola? Well, our vertex, or h and k, is going to be 3 minus 4. Meaning that we can substitute this into our equation as y is equal to a times x minus 3 squared minus 4. And now all we have to do is pick a second point to determine what this will equal. Let's go with this point over here, 1, 0, and see what that gives us. Y is 0 is equal to a times 1 minus 3 squared minus 4. Okay, from here we're going to solve, so we'll get 4 is equal to a times minus 2 squared. The minus 2 is inside, so this is minus 2 times minus 2, or the negatives will cancel out. This will be 4 is equal to a times 4, or a is equal to 1. Meaning our equation will be y is equal to 1 times x minus 3 minus 4. And this is why vertex form is useful. All we need is our vertex, and we can solve for these parabolas easily. However, this isn't the easiest way to write it. That would be standard form. Standard form we have a lot of information for. What standard form is it's y is equal to ax squared plus bx plus c. This is the form we're used to seeing quadratics in. Now we have some properties here. Let's take some notes. The graph of a standard form, it's a quadratic. The graph of a quadratic is always a parabola. If a, just like with the vertex form, if a is greater than 0, or if a is positive, it opens up. If a is negative, the parabola opens down. This is where we get a little bit more confusing. The axis of symmetry goes through the point x is equal to minus b over 2a. This is just something you're going to have to remember. The x value for the axis of symmetry and for the vertex is minus b over 2a. The y value is whatever happens when you substitute that x value into the equation. So it's the output of the function when you use that point. And the y-intercept is 0, c. So it's just the constant for this equation. Your y-intercept will always be c. Your vertex will be negative b over 2a, and then you'll substitute that value in. That's really all we need to know. So let's go ahead and do some practice problems with this. We're going to algebraically determine the location of the yint, or the y-intercept, the axis of symmetry, the vertex, and a mirror point, and then graph this function. So we have the function y is equal to x squared plus 2x plus 3. Our y-intercept is the constant. Our y-intercept is c, so this is the point 0, 3. Our axis of symmetry we said was x is equal to negative b over 2a. So a is 1, let's write this out, a is 1, b is 2, and c is 3. Meaning that our axis of symmetry is going to be x is equal to minus 2 over 2 times 1, or it's going to be minus 1. So our axis of symmetry is x is equal to minus 1. And what is our vertex? Our vertex is going to be whatever happens when we substitute minus 1 into the equation. So y is going to be equal to minus 1 squared plus 2 times minus 1 plus 3. We finish solving for this, we get 1 minus 2 plus 3. That's going to give us a value of positive 2. Meaning our vertex is going to be the point x is minus 1, y is positive 2. Let's go ahead and throw that on our graph. We get minus 1, positive 2 as our vertex. We know our axis of symmetry also runs through here, meaning that if we have a point on one side, we can make it an equal and opposite way across the axis of symmetry. And we do have another point. We have the y-intercept at 0, 3. So we can plot that on, and we can plot this 1 unit across on the other side. And this is our 3 points that we need to make a parabola. You're always going to need 3 points to make a parabola. And that's going to be the basics of our function. The equation in vertex form. So in vertex form, a will be the same. So y is equal to, what was a originally? It was 1. So this is going to be y is equal to 1 times x minus, our vertex was at minus 1, so x minus minus 1 squared plus 2. Now you all go ahead and try this. What is our y-intercept? What's our axis of symmetry? What's our vertex going to be? And what's the equation going to be in vertex form? So when we're doing this, our y-intercept is going to be c, or our y-intercept is going to be the point 0, 3. Let's go ahead and throw that onto our graphs again. Our axis of symmetry is going to be at the point x is equal to minus b over 2a. So this is going to be x is equal to minus 4 over 2 times minus 2, or this is going to be positive 1, meaning our axis of symmetry is at positive 1. And to find the vertex, we know the x value will be 1. The y value will be equal to, y is equal to minus 2 times 1 plus 4 plus 3. Or this looks like it'll be minus 2, so that'll be 2 plus 3, 1, 5 is our vertex. From here, we plot this out. We go to the point 1, 5. We run our axis of symmetry through the vertex. And we draw a point equal and opposite across on the other side of the axis of symmetry. So we move 1 across, and we graph our parabola. Now in vertex form, a stays the same, so this would be y is equal to minus 2 times x, what's our vertex, what's h, is 1. So it's x minus 1 squared plus 5. And to wrap this all up, we have a problem to force us to think about this a little bit in terms of applications. Let's say that we have some equation here, and it represents the height of a ball as it's kicked through the air. H will be our height, and x will be the number of seconds. We're going to use our knowledge of the y-intercept, the axis of symmetry, and the vertex to answer this. Let's create a sketch though. We're starting off, we have somebody here, and they're kicking the ball. As we remember from physics, the ball is going to go up, and then it's also going to come down. If we look at this, this looks a lot like a parabola. So let's use that to our advantage. How many seconds will it take for the ball to be at the highest point? Well, our highest point is going to be the maximum. How do we find the maximum of a parabola? That's going to be the vertex. And since we're looking for the time was our x value. So we say that our time, x, is going to be equal to minus b over 2a. Or our time will be minus 0.6 over 2 times minus 0.2, which will make this equal to 1.5 seconds. And this is our solution for the time. What's the highest point the ball will get to? Well, the highest point will be the y value for the vertex. Meaning that all we're going to do is we're going to substitute this point 1.5 seconds in for x. We'll get h is equal to minus 0.2 times 1.5 squared plus 0.6 times 1.5 plus 3. And we throw that into our calculators. Plus 0.6 times 1.5 plus 3. That tells us the highest height we will reach is going to be 3.45 feet. And finally, what's the initial height of the ball? Well, the initial height is just c. The initial height is just c, meaning that we can say that the initial height was, if we go back up to our equation, 3. Our initial height was 3 feet. Right, there you have it. Go ahead and get started with the homework.